Welcome to The Explainer. Today, we're diving into a really fascinating new paper that proposes a clever way to teach AI a skill it's, let's be honest, notoriously bad at: genuine, open-ended creativity. So let's start with this question right here. You've probably noticed this yourself, right? AI models have gotten absolutely incredible at tasks with clear, verifiable answers, things like math or programming. But the second you ask for something subjective, something truly creative, they often just fall flat. And this isn't a small issue. It's a huge bottleneck in AI development, and it's the exact problem this new research paper tackles head-on. So here's our game plan for today. We're going to dissect how these researchers are basically flipping the script on AI training. We'll start with the core problem, then introduce their pretty radical new solution. We'll see how it actually works, and then we get to the jaw-dropping results where a small model punches way, way above its weight. And finally, we'll wrap up with what this all means for the future of AI. Okay, so section 1, the creativity problem. To really get why this new paper is such a breakthrough, we first have to understand why teaching an AI to think creatively is so ridiculously hard. It really just boils down to the limits of the two main ways we train these models today. So, on one side, you've got reinforcement learning, or RL. Now, RL is great for something like a game of chess, right? There's a clear win or lose state, you can give it a reward. But how do you score emotional resonance in a story? How do you give a reward for a beautiful metaphor? You can't, really, which makes RL kind of useless here. The other path is instruction distillation. This is where you get a huge, powerful teacher model, like a GPT-4, to show a smaller student model how to think. The problem? Well, it's crazy expensive. And your student model can never, ever get smarter than its teacher. It's a built-in ceiling. So this is where the paper comes in and introduces a brilliant third path to get us out of this jam. It's a whole new way of thinking called reverse-engineered reasoning, or RERR for short. And the core idea here is just so clever because it's completely counterintuitive. Instead of trying to teach an AI how to reason its way to a good story, REER starts with a brilliant story, one that's already written by a human. And it works backwards. It asks, okay, what's the most logical step-by-step thinking that could have possibly led to this masterpiece? It's literally reverse engineering the creative process itself. So you're probably wondering, how does this thinking backwards thing actually work in practice? I mean, how can a computer look at a finished story and figure out the thinking that went into it? Well, the secret sauce is a metric called Perplexity. Now, the easiest way to think about Perplexity is as a measure of a model's surprise. See, a really good creative plan should make a great story feel logical, almost inevitable, not surprising at all. So the goal of RER is to find the reasoning path that minimizes the model's surprise when it sees that final high-quality story. And the way it finds this least surprising path is through a simple but really powerful four-step loop. First, it just generates a rough, kind of bad initial plan. Then, for each step in that plan, it brainstorms several better, more detailed versions. Step 3 is the key. It evaluates each new version by checking which one makes the final story the least surprising. Which one has the lowest perplexity. It picks the best one, and then it just repeats this whole process over and over, refining the plan until it's as logical and coherent as it can be. So, using this really cool method, the researchers generated a brand new, totally open source dataset they're calling Deep Writing 20K. It's got 20,000 of these reverse-engineered thinking plans, or deep reasoning trajectories. And what's really crucial here is that almost half of the entire dataset is focused specifically on artistic and creative writing. They're going right after that core problem we talked about. Okay, this is where it gets really exciting. They took this new dataset and they used it to train a model. And the results? I mean, they're frankly stunning for a model this size. So let me introduce you to DeepWriter 8B. Now, this is not one of those massive, closed-off proprietary models. It's an 8 billion parameter open-source model, which is pretty small by today's standards, and it was fine-tuned only on the data they created with REER. Let's look at the numbers, because this is pretty wild. On the creative writing benchmark, DeepWriter 8B's score is basically a statistical tie with GPT-4o. That's incredible, but look at the academic writing column. It demolishes Claude 3.5 by more than 13 points. So this little 8 billion parameter model isn't just hanging with the giants. In some cases, it's actually winning. But maybe the most shocking result of them all was on a benchmark for generating super long, coherent text. Look at this chart. DeepWriter 8b didn't just compete with GPT-4o and Claude 3.5, it actually beat them outright. This really suggests that teaching an AI how to plan its writing gives it a massive advantage when it comes to staying consistent over long stretches.
Okay, so what does all of this mean for you? Whether you're a developer, a researcher, or just someone who follows this stuff closely, let's break down the key implications.
Well, for starters, RER gives us a brand new, scalable, and much cheaper way to create powerful, specialized models. You don't need expensive teacher models or finicky reinforcement learning anymore. It also proves that smaller open source models can achieve truly world-class performance. And maybe best of all, the community now has this powerful new deep writing dataset to build on and push creative AI even further. All right, let's wrap this up by zooming out and looking at what this breakthrough might mean for the future of AI reasoning. You know, the paper itself says it best. This isn't just a small step forward. REER really is a fundamental shift. By solving a core problem in such a novel way, it doesn't just give us one better model. No, it opens up an entirely new road for research and development in AI. And that leaves us with this final, really tantalizing question. The researchers managed to reverse engineer the reasoning behind great writing, but what other complex, subjective, uniquely human skills could we teach an AI by doing the same thing? Things like strategic thinking, or empathy, or maybe even humor. If we just work backwards from examples of human excellence, suddenly the frontier of AI just got a whole lot more interesting.